In this module, we look at wood, a naturally grown product, and wood cells are the basis of all structural timber. So by understanding the way wood cells are going to work, we can better use structural timber. We'll look at carbon and sustainability. We'll look at the cells themselves and the way moisture affects them, the way they shrink, and the way they creep. Firstly, carbon. Trees make use of photosynthesis to take carbon dioxide out of the atmosphere, and it locks the carbon away inside the trunk of the tree. That trunk becomes timber, and the wood cells become the structural timber that we use as structural engineers. About 50%, about half the weight of the wood in a piece of timber is carbon, and that carbon has come out of the atmosphere. So trees are really good at removing carbon from the atmosphere, and the longer the timber is in service, the more the carbon is out of the atmosphere. Using timber is actually beneficial to the atmospheric carbon cycle. Timber is renewable. It takes about 30 years to grow a tree in a plantation forest to create structural timber. Thinking of it in terms of personal use of timber, it takes about 10 minutes for Australia's forests to grow enough timber to produce a single house. It's reusable. In the central photograph on this slide, you can see a building that once was a wharf and now is a set of apartments, still using the main structural elements that were put in place, pieces of timber, over 100 years ago. Waste timber products can be recycled as chip, so that even the pieces of timber that don't necessarily make it into structural applications can still be used in other products. By understanding the nature of the timber, we're going to choose appropriate timber products for appropriate uses and detail connections properly as well. Hardwoods and softwoods. The difference between a hardwood and a softwood is botanical. But as structural engineers, we're interested in their properties. Both of them grow exactly the same way. So in a tree, it's the outside where the new cells are laid down immediately underneath the bark. Those cells are all laid down as hollow pipes. And if we look at the cross-section through a microscope of the timber in this slide, you'll see that the wood fibre itself is a whole bunch of hollow pipes in the actual tree. If we look at hardwoods and softwoods, we see that the cell structure is slightly different. In the softwoods, the cell walls are thinner, and this gives them a lower density. The hardwood structure is a more closed structure with much thicker cell walls, and that gives the timber a much higher density, and also often a darker colour. In terms of structural performance, the cells function differently in different directions. If we load the cells parallel to the direction of the cells, we find that they have very large stiffness and high strength as well. On the other hand, if we load the cells perpendicular to their axis, we find that they have low strength and low stiffness in both tension and compression. So they squish up easier in compression, and they can actually lead to splitting if we load it across the grain in tension. Now those cells in a growing tree are full of moisture, so that there is water in all of the cell voids, and all of the cell walls are pumped up with water as well. In terms of production, we remove as much moisture as we possibly can out of the tree as part of the production process. And we wind up with hollow voids in the centre of the cells, and the cell walls have reduced in thickness as we've taken some of the moisture out. We tend to target around 15% moisture content, and we call timber that has been dried to 15% seasoned timber. Well, that's the main source of structural timber. Most of our structural timber products are seasoned. Wood is hygroscopic. It soaks up moisture from the atmosphere. If we take dried wood and put it in a moist atmosphere, it actually pulls moisture out of the atmosphere into the cells and plumps up the cell walls a little bit extra. On the other hand, if we take moist wood and put it into a dry atmosphere, it will give off moisture into the atmosphere, and that will cause each of the cell walls to become a bit thinner. Atmospheric moisture in equilibrium with the wood moisture varies according to the surface conditions. If we have an air-conditioned environment, it dries the air out quite substantially, and timber that has a lower moisture content will be in equilibrium with that atmosphere. So in an air-conditioned environment, timber with a moisture content between 8 and 10% will be comfortable alongside the dry air in that environment. On the other hand, outside where the air has a higher moisture content, timber will want to have a higher moisture content. It responds to the changes of moisture content by moving. And because it's the cell walls that are getting slightly thicker or thinner, it's going to shrink or swell perpendicular to the grain. There is a video clip on moisture in timber that explains this in a little bit more detail. But we get movement of timber in service of generally around 1 to 2% perpendicular to the grain, and about 1/10 of that parallel to the grain in the pieces of timber. Finally, the wood cells respond to compression strength by moving a little, so that under compression a load can be applied, and if that load is sustained for a long period of time, the cells are going to get slightly shorter. Again, there's a video clip that outlines creep in timber, and it's essentially something that happens at a microscopic level in the compression side of any bending member. So in summary, wood is a natural material, and wood is the basis of timber products. Timber properties are determined by the way the wood cells behave under load. Timber is strong and stiff parallel to the grain. So if we take a piece of timber and load it parallel to the grain, that gives us a great deal of strength and a great deal of stiffness. On the other hand, loading it perpendicular to the grain has lower strength and lower stiffness. Moisture does move into and out of the timber in service. It does affect its size perpendicular to the grain, but it doesn't change its length appreciably at all. And finally, in a bending application or a compression application, the timber does respond to moisture and duration of load by creeping. All of these are things that happen because timber is a natural product. And if we understand the way the timber performs, we're going to be able to design it to get best possible structural use out of this really beautiful and amazing structural product.